Greetings and salutations, everyone. I hope everyone's having a good Monday. Sorry for missing out on a couple of days. But I wanted to kind of go over a couple of things and talk about a couple of things. One, the next project that I'm going to work on is called Reverse Bullet Hell. But I also wanted to talk about, for those people who are new software engineers, which I imagine nobody is, but there might be a few beginning software engineers. I think there's kind of two different approaches that you can take, and I wanted to kind of go over one today. In terms of software development, I think there are kind of two general approaches. General, and again, there's probably more than that, but I guess I'm going to kind of start off with this kind of the two. You can kind of do like the database approach first, or you can kind of do the top-down approach. I find for me personally, I like to do the database approach first, or the back-end approach, if you will, and it's only because it helps me visualize all the pieces that I'm going to need from the back end first and can kind of build up from there. So kind of as an example app, I'm going to start off by building something that tracks stock options, or when a person trades stock options. So from that particular perspective, you kind of have to have a good understanding of how it works to begin with, and then you can kind of design your interface around that. And again, this is where I was saying you can kind of go from one side to the other, or go from one approach to the other. One of the things that I find very troublesome is that when you go top down, your interface is built, or your backend is built to kind of deal with the interface, and it may not necessarily follow good rules in terms of development or design. So for instance, one of the first pieces that we'll start off with is kind of your user piece here. So let's zoom in a little bit. So you're going to have your user table that we're going to start off with. And again, everyone's different. So let's not even start there. Let's start off with what technologies you may want to use. Some people feel very strongly about Node. Some people feel very strongly about C# or Python or anything along those lines. I would generally suggest, just like tons of other developers out there, that you pick something that you're comfortable with. Now, unless you're trying to learn a new programming language, you know that this is going to ultimately scale out into something larger, then go with what you're comfortable with. Go with what you use every day. Give me 1 second. So for instance, for this particular project, I'm going to use Nest.js. Now, understanding that I may run into problems down the line in terms of scaling with this application, but if you're just building a fairly small application, or an application that may not scale, then going with something like Node might work. If on the other hand that you might need to worry about scaling, one of the things that you may want to sit down and figure out is what programming language you want to go with. And then of course, you have your Python, you have your Java. I must say that I feel kind of strong about things like C#. So I would generally lean towards C# myself. But knowing this is just a small personal project, I'm going to use Nest. And that's because I find it very quick to set up and get everything running, so forth and so on. So I've already kind of decided that for the back end, I'm going to use Nest. Now for my database, and again, this is going to come down to personal preference, but I mean, you also want to sit down and think about how you're going to use this particular application. For a database, for instance, you have your NoSQL databases like MongoDB. You have your free open source ones like MariaDB or MySQL. You have a bunch of different options, and you don't necessarily have to feel tied into one, and you can use multiple. But you probably want to take a moment and think about what type of interactions you're going to expect. So for instance, if a lot of our data is kind of straightforward, and it's not necessarily connected to each other, not to say that Mongo can't connect things to each other. I would probably lean towards a SQL database if our data is relational. I would lead towards MongoDB if our data is not relational. And by relational, I mean that if, for instance, you're looking to connect your user table to a profile table, and from your profile table to another table, and then another table, and then another table, it's very relationship based. And in this particular instance, since we're building a stock options application, and we'll put it up here, option application. Since we're building a stock option application, our database is going to be very connected, because what we're going to want to do is we're going to want to make connections. So we're going to want to see what stocks we traded, when we traded them. We're going to want to create charts that say, okay, on this day you made this much money, or between these two periods of time you made this much money. And again, you can also use MongoDB for aspects or pieces of it, but I think that for this, a relational database is probably where I would go. And again, it doesn't mean that you can't. But if you're not going to store it in, say, MongoDB, if you're not going to store it in SQL, then you may want to think about how you're going to store the data. And that is going to come down to things like, if I know that I'm going to need to very quickly pull in a bunch of data for my front end, let's say I want to do a report, I might instead have it so that every time I put in an option, or before I put in certain amounts of data, I break it up and do some of those calculations beforehand, so that I can very quickly pull that data back. Now, in that particular instance, and again, as an example, so knowing that you're going to want to see what was traded on what day, you might take, let's say, somebody's option trade and say, all right, well, I've broken it down into, what stock I traded for the day. You might break it down into the amount that was traded for that particular day. So then you could very quickly see, and you might put them together, might do stock and amount, but then you can very quickly see what the pieces are going to be, and so that you can recall them and you don't have to necessarily make other calls out to the Mongo database. Whereas with SQL, you can just kind of say, all right, connect this database, this table to this table to this table, and pull back this. And again, you can also use multiple things. So if you want to, for instance, keep the user login very quick and speedy, but you know that the report data might need time to scale, you can kind of do two separate databases. And in this particular instance, that might be a good example. So I might use, knowing that I'm going to keep kind of a trade journal going, I might use MongoDB for the trade journal. There's nothing special or spectacular about the trade journal. It's not necessarily going to connect to any other aspect of the application. So knowing that I'm going to want to be able to quickly recall log after log after log of our data, this might be a good place for us to use the trade journal. So we'll put the trade journal over here in the MongoDB, and then the SQL will contain our stocks, options, etc. So this might be, a good approach for that. Now, this just handles kind of your database and your backend. Now, another factor that I'm not kind of, thinking about here, another piece that I'm not actually talking about or thinking about here is things like how it's going to cost. And those are something that I think everyone needs to think about if they're thinking about scaling or putting their database out there. And there's a whole other discussion that can kind of go into that. So you might sit down and say, well, I really love Node, but you might find out that spinning up a Node environment and then leaving it out there on, say, a cloud environment just costs you so much money. Whereas a C# application or a Python application or another application might be able to be spun up pretty quickly and then just kind of sit out there and be fine. So those are some of the things that you can think about. In this particular instance, I'm not going to go into that. I think I will as I start working on the next application or showcasing that, so that you can kind of see step by step some of the thought processes that architect or designer or developer might go in to kind of figure out how can I build an application that I know is going to scale, and think about, all right, costs, so forth and so on. So those are the things that you might want to think about. But again, for people who are designing kind of their first kind of fun application, something that they might want to show off to someone, this is a prime example where you can just kind of build it for fun and worry about some of those aspects later, knowing that you're never going to have to worry about scaling it up past the point. Now for the front end, you have a bunch of different choices. Now you have Angular, you have React, and then you have variations of those frameworks. React has a couple different frameworks like Next, not Nest, but Next. And then you have Svelte as an example. You could go Svelte. So you have a bunch of different options there that are available to you. And again, this is where you have to kind of figure out how you want to engineer it. Now, those coming out of some of the boot camps might be like, well, I'll have my back end serve my front end pieces. And again, there's nothing wrong with that. But you also want to keep in mind that you might want to, as your back end, you may want to keep it separate. You may want to keep it separate so that as you perhaps move into, for mobile, or if you're going to have multiple interface from mobile and desktop. So you're going to have an interface that you're going to want to think about for, I keep my API separate so that someone could access from either mobile or desktop. And then you may not serve the pages, if you will, kind of have it so that Nest hosts your back end. So that Nest hosts your front end. You'd keep them kind of separate. Now, I think React has become far more popular these days, though, of course, there are all variations of it. And you have Angular, which I don't know if is nearly as popular. I guess we can do a quick, do a quick popular front-end frameworks. Yeah, let's do a quick look. So there's always an article that talks about the best front-end frameworks, blah, 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 blah. And it looks like what we're starting to see, at least according to this, Svelte has started to pick up popularity. Concludes that React is 64%, Svelte is another 62%. What? That's not possible. That seems weird. No, you can't have 62 and 62%. But all right, React and Svelte and Vue have received the most positive ratings. React has the highest retention ratio, with 57% of developers planning to use it again, followed by Vue.js and Angular 17. However, when it comes to being for the future, Solid, Quick, and Svelte are the top 3 frameworks developers wish to learn. However, many frameworks have sparked little interest in developer community: Ember, Alpine, and Preact. You could go for a lot of different things. In this particular instance, just for kind of speed and time to get things going, I'm just going to use React, and I might use Vue for something else. Language Berry with plugins and components. So I'm going to start off with just React. But again, everyone go with what you're familiar with when you're building these kind of custom projects, because again, you're going to be the one that's going to be building it. It's kind of for your portfolio. It's something to kind of go on. So in this particular instance, we'll use React, and we'll probably use Redux, and probably specifically Redux Toolkit to kind of make it happen. So Redux Toolkit to kind of make that happen. So I would kind of start here. And again, this is my approach. Now, everyone's a little different in how they approach things. But I would kind of start here with knowing your React, your Redux, knowing your backend, and how you're going to do your database. Now, I again like to go from back to front approach, because again, if I design it based upon how a person is going to use it per se, it may not follow good good approaches. So for instance, when a user logs in, you might not think about some of the little pieces that you might need for your actual database. So for me, I like to start here. So I'm going to start off with my user, knowing that I'm going to have a login. And for my login, I'm just going to use JSON Web Tokens. There's some really good tutorials out there. I would say BezCoder has some pretty good ones, but there are a ton of different ones. Let's take a quick look. And since we're using Nest, we'll have to, play around with that. So we have our user here, and we've done some Nest stuff before. So we have our user database here. We're going to give it an ID. I've come to appreciate GUIDs over straight integers, but if you don't feel comfortable with GUIDs or what they are, then I would just go for a normal ID. But the thought process or thought pattern might be, okay, I've created an ID, and what happens when I want to scale that up? So like, how many records do you want to potentially hold, and are they going to be unique enough? And so I like to use GUIDs, but let's take a quick look at that since we're here. Let's do GUID verse int for GUID verse int for primary key. And let's take a look at what some people have said about it. It's unique across every table, every database, and every server, allows easy merging of records, so that's nice. It's 4 times larger than the traditional 4-byte index. This can have serious performance and storage implications if you're not careful. It's cumbersome to debug, like they say, and the generated GUID should be partially sequential for best performance, and enable use of clustered indexes. So here's some very good examples. So on the phone, you might create one here with, a unique ID here. And they point some things out. It's the massive fragmentation, sequential GUIDs are only sequential until SQL instances restarted. So some people prefer to use both. There's not one size fit all. Everyone's going to be different on how they approach it. And it looks like, it depends. Log file activity, full recovery. Best practice index. Here's the video link. So you could use both. So instead of having the GUID where it takes up with a separate table, and again, these are all preferences. These are all the things that you can kind of debate and go back and forth on, and so forth and so on. And they're right. It's a challenge to merge records from different databases. Distributing data across multiple services is difficult. It's easy to duplicate. It's larger than int. Performance issues and storage issues. It's not auto-generated. I don't know how much we have to worry about that with this particular small thing. I would say go with whatever you feel. In this particular instance, I'm going to use a GUID for an ID. We'll have an email address, which we know will be a string or varchar. And we'll do a password, which is going to be the same thing, string or varchar. And in this particular instance, that's all we're going to have to kind of start off. In this particular instance, since it's just for a stock application, we know that already we're going to use a trade journal, so that'll be a fairly easy setup. We'll create a journal table in our MongoDB. That journal table is going to have the ID, and it will be the journal ID. And we'll actually make this a little bit more specific. So this will be the user ID. So we'll have the journal ID. It'll be the GUID as well, and that'll come from MongoDB. We'll have the user ID, which will also be a GUID. and then finally we'll have the journal, the date, the journal entry, which will make it text, and we'll have the date, which will be a datetime object, so that we can record. So if someone puts in multiple journal entries in one day, and it'll just be a very quick journal entry. Next, from a back-end perspective, and again, this is because I have knowledge of options, I'm going to want to keep track of each trade. And a trade will consist of one or multiple options. And that option is going to consist of, it's going to have an option ID, which we're going to be a GUID, and that option will consist of a stock, which will be a string or varchar, and then it will consist of a strike price, and that will be a double here. You'll have a double or decimal, whichever one, double, decimal. You'll have a strike price, and then you're going to have to know whether that option is the strike price. We'll have the price of that particular option, which will be either double or decimal. And then we will have, oh, somebody messaged me. Let's take a look here. One of my many browsers, because I don't know which one is which. So we have our price of that particular option, the strike price, the stock that it's going to be attached to, and whether it's will have an option type. And the option types are going to be either put or call. And it's also going to be, we'll actually set it up to be an integer. And it's going to be an integer because we're going to have an option type table. Though there's only two, we actually probably don't need an option type. We really can just say, we can just, have it be a static 1 or 2. Give me a second. So we'll have an option type, which is just going to be either a 1 or a 2, because there's only 2 option types. You either put or call. For an individual trade is going to have a trade ID, which will be a GUID. We're going to have the option that goes along with it, and that'll be connected to an option ID. And then from the trade ID and the option, we're going to have the quantity that they trade. Let's go ahead and silence this. Yeah, focus. Clock needs an update. We are getting the update ready for you. Yeah. So let's put this in as what? Why are there updates? Why can't it just be a thing? Like, it has it as a feature. What's going on, Windows? Why do you do this? You're like, we're gonna offer you this thing. All right, cool. Focus period 1 of 2. This is terrible. Let's go over here. In session. Let's focus again. We got 20 minutes. All right, cool. So you're going to have the quantity of the price of the trade. So how many of these options did you or did you not buy? And that will just be an integer. And after that, you will have the price that it cost you. And we should probably call this trade price so that it's unique. And it will be a double / decimal. And this should be the option price. And again, these are some of the things you may want to think about when you're going through and designing stuff. And then you should probably keep track of the date time that this happened, the date that this option was available, date time, the strike price, and you need the expiration date for a particular option. So stock strike price, option type, and the expiration date. And this is just going to be date. We don't need the date time. And we need to know this is when it expired, and the trade will actually be when we bought it. This will be the date that we bought it, which is going to be a date time object. And that should be it. So we'll do a trade. It'll have a specific option attached to it. We'll have the quantity, the buy price, and then the sell price that we're going to use. And once we kind of have all of that, each trade will have attached to it a user ID. And each option will also, each trade will have, so an option ID that goes along with it that's going to be a GUID. So an option belongs to a trade belongs to a user. And potentially we could attach a journal to a trade. So we could make that this is going to have a trade ID, a GUID, and we'll make it optional. So all right, so we have our user, we have our journal, we have our trade, and we have our options, and then we're going to have to put in all of this. Some of the things that you may want to think about when you're designing your application is what things you want to check for, type of error handling, how you want to link these things together. And so here's an example of what you might want to sit down and do or take notes on. Is you might want to say something along the lines of user ID should have some type of constraint with user ID, so that we know that that's going to be the case. Now, it's probably obvious that user ID should match, but just in case, you might want to take some notes of those constraints, especially if you're going to work with this project with anyone else. So you're going to have your trade, you're going to have the options that are going to connect it, and then you're going to have your trade journal if you feel particularly strongly about something or otherwise. And this just means that when you go to look at some of this data later, you can sit down and look at all of the stocks that you traded. So you want to say, okay, give me all of the stocks, all of the options that I traded, the average price, the time that I bought and sold. And this is something that you can kind of refine as you go along. So the buy date time and the sell date time. And this is all going to be dependent on each individual project that you work on. Some people feel particularly strongly about tracking a lot of information, and I would say that if you're looking or thinking about larger scale applications, the following should be kept in mind. Most people and most companies want to be able to track data later on. This is a big flaw that I think many developers early on don't always think through, is companies do want to track data. They want to know all of the nitty-gritty details that I think some people just kind of gloss over. But those information, that particular information, drives metrics. It drives so much for companies. They want to know who used the app, when they used the app, what was going on, what was the thought processes behind it. And sometimes you don't have that information, but they want to at least be able to know that information so that you can kind of go, from there. And as you're building the application, or as people are using the application, you want to be able to track that stuff down. Now, again, since this is kind of a custom application, that nobody besides you is going to use, or even potentially see, then you have a lot of leeway there. But it's just something to keep in mind. So now we kind of have the general design of our application. We have our React app. We're going to use Redux Toolkit for Redux and to keep things local. We have Next.js that's going to be on the back end. We have SQL that's going to be used for our relational database, and MongoDB for our trade journal. Now, again, more than likely in this particular instance, we really could just keep the trade journal inside of SQL. And in all actuality, because we are going to connect it, we would just keep our database in just one place. So we would just use SQL for this particular instance. So this is an example of how one might kind of plan out their small application. And of course, you can always add things on, but this is a good kind of starting point. And again, just going with the technologies that you feel comfortable with, so that you don't, and not to say that as, again, a senior developer or something like that, you can totally practice and do things. But I think this is not, when you're building an application coming out of a boot camp, or you're a beginning or junior developer and you're trying to get in practice, this is always a good way to kind of pick something that you're interested in, that you're passionate about, and kind of go from there. Don't get me wrong, games are great, and I do think that there are a lot of people who love to build and make games, but I don't know how applicable that is in everyday life all the time. If you work for a game company, or you want to work for a game company, or you're building your own game, then it's great. But there's a lot of other areas where where developers are needed, and being able to kind of think about how I want to build a feature or a function or a component, so forth and so on, is very important to have. Just because, again, there are just so many other applications and times when you're going to need to think about this, aside from just the game mechanics. And not that game mechanics and games don't have their place, but they may be designed differently. You may not need to. So, for instance, for a fairly small front-end game, and small is relative, you may not necessarily need a database. You may not need to think about user logins and all of that stuff. So you may not need a backend or a database. So these things, I think, are really good for early developers to kind of sink their teeth into and kind of play around with, so that they can kind of get used to this thought process. Let's go ahead and open up our project, so that we can kind of see what that looks like and how we might start off. Now, again, we're going to use Next.js for this. So here we have our option tracker. Now, because we have our database kind of in a separate spot, we don't have to think about this. But we're going to kind of break it down so that we have our backend. And now Next.js and React both have their own ways of installing. So we're going to put each one in their own individual folders. So let's start off with Nest.js and kind of go from there. Let's go to its documentation and follow the steps. So we've already installed it before, and then we would just say nest new project, and voila, that would allow us to create it. So knowing that, we can come over here to our terminal. We have our option tracker, and we can just say nest new, and we're just going to call our backend server or backend. So to kind of keep it really clear, we'll just call it nest new backend. We're going to use npm. Some people have a preference for yarn or pnpm. npm is just fine for me. It's going ahead and doing the install for all the pieces that we need. And just takes time. All right, cool. So, like I said, Nest has its own approach for installing things and keeping everything kind of clear. Let's zoom in a little bit on this. Zoom to 150. Cool. So Nest already has its own particular approach to this. So here's our back end, kind of already at least scaffolded out, if you want to call it that. And then we'll do something similar for the front end. We'll just use the native React. So we'll do npx create React app, and we'll call our front end just to kind of keep it in line with what we've documented here. So we'll have our front end and we have our back end. So we'll just do that. Wait for that to finish installing. And now there is, knowing that we're going to need to run both at the same time at one particular point, there is a really neat library called concurrently. Now, one of the ups and downsides, of course, of using Node is that Node makes things very easy because of npm, but at the same particular point, if a developer who made a library decides to tank that particular library or take it down, you're kind of just stuck. And that's not always great. But hopefully that won't be the case. So you have your front end here, and then you have your back end here. Excuse me for one moment. Sorry about that. So we have our front end and we have our back end, and on our surface level, we're going to install concurrently here. We're going to do npm I to init, npm init, and let me open up my Visual Studio Code. So we have our Visual Studio. Yep, we're just going to call it option tracker v2 is fine. Version 1.0, no description. And now some of this stuff is stuff that you might care very strongly about. So our index is just gonna, we can call it index. I don't really feel that strongly about it. So to kind of get things set up, we're going to install something called concurrently, and use that to kind of run both applications at the same time. So let's go ahead and do that. We'll do npm I and we'll install concurrently. And in this particular instance, we're just gonna go ahead and set up things so that they run as development environments. So we'll come over here to our package.json. We'll come over here to our scripts, and we'll create something called start dev. And now, eventually we're going to have a start prod, but for now we'll just do the start dev. And here's where we would use concurrently. We would say quote concurrently, and we're actually going to navigate into the various folders and do what we want. So let's go to our backend. So we'll cd to backend, and we will run npm run start dev. And that's what we'll run on the back end. And then on the front end, we'll cd into that. Front end, if I can spell here. we will do an npm start. And I guess we could literally do npm run start, but I don't know if it matters that much. So that's going to be our command to start everything. That'll get concurrently started. And the only other thing we may want to do is take a moment to block off or create some node module changes, so that we don't, some git ignore changes, so that we don't pull in node modules when we don't want to. So let's go ahead and do that. So let's look. There it is. My classic. Oh, I guess I didn't include it. So we could just create a git ignore. Let's just do it manually. New file dot git ignore. And more than likely, for those who have ever worked with WebStorm, you're going to want to ignore your node modules. And you can kind of use, in either one of your directories, if you're using something, you can kind of use this as an example. So we'll put it right next to it. On our main level, our git ignore, we're going to want to get rid of node modules. We don't want to allow that. We just don't need that folder. And we're also going to want to ignore the .idea folder. Now, I don't think there's anything else that we specifically need to ignore. We could ignore project and class paths and so forth and so on. And we could grab all of this stuff as well, just in case we open this folder in VS Code. So let's put that in there, and that will give us all of our git ignore stuff. So now we have our backend started, we have our front end started, and we have a git ignore set up. All right, so let's go ahead and start tackling some of our backend pieces. Now, the next step in this particular instance with Nest.js is, I would say, going ahead, we'll just say done for right now. Done. Now, at this particular point, I would say that the thing you'd probably want to do is start adding in your various libraries. I would say that you don't have to document those libraries. I would say that it is handy and useful to document those libraries, and not just for randomness, but I think it's important for a number of reasons. One, eventually you'll turn this into perhaps a README, and actually we might as well do it right now. So let's go ahead and create a README for this. New file. Let's do a README. So we'll create a readme.md in here, and then we can document all the libraries that are used, and we can document other information so that if we come and look at this particular project down the road, we can see all the libraries that we've used very easily without having to necessarily play the weird game of running npmi and hoping that we know what we're doing. But it also allows us to then easily see what we've used, and other people can easily see. I just think it's handy to have. So let's go ahead and grab all of this. And now, whether or not you choose to display all of that information whether you choose to display all that information, such as your database layout, in your README is completely up to you. So let's document some of this. So let's put an H3. This is our front end, and it's going to use, I don't know if there is tabbing. I guess Front end's going to use React and Redux Toolkit. And our back end will do your H3. So we'll do an H3 and yeah, let's stop the session for now. And then on the back end, we're using Nest.js. And our database is going to be SQL. So we'll set you up with an H3 tag. Database is SQL. And we'll put you here. There. All right. And so under here, I would probably kind of list off some of the apps that we're, or the items that we're using. I know we're going to use Redux Toolkit. We are going to use Bootstrap. I am going to use Fund Awesome. I just know that I am. And off the top of my head, I can't think of anything else that I want to use. I will probably use the React routing, but that's kind of built in. On the back end, we are going to use Sequelize, and we are going to use the MySQL 2 library. The database, there's not much to do there, but under database, we may want to sit down and put in, and very specifically, we're using MySQL. We may want to put in our database structure. And this may change over time, and you don't have to put in your database structure. Oh, I do know something we are forgetting here. We are going to use an environmental variable. So no environmental variables. We want to use, what's the name of the library? Why can't I remember it? Yeah. Let's see. No. .env file. Yeah, there it is. .env. Don't know why I didn't remember. We are going to use .env. And some of these we can just go ahead and install now. So if we want to, let's go over here to our backend directory, td backend, and let's install MySQL 2, Sequelize, and .env. And that'll give us everything on that side. And on the front end, knowing that I'm going to install these, cd ... front end, not font end, but front end. And let's go ahead and install Bootstrap. Let's go look up all the things. Bootstrap for React. And let's look up Font Awesome for React. And here you have those kind of already set up for you. Follow just the getting started rules, and you just install npmi, React Bootstrap, and then there's more to it. And then for Font Awesome, it's going to be probably something similar. Let's go to the get started. So kind of make this easy, we'll just do npmi. And it looks like we would do all of these pieces here, and we'll let that be. And then on the React side, we would do this. So to kind of tie it all together, we'll do Bootstrap. We'll install Fort Awesome core, and then we'll grab free, and then we will grab the font Fort Awesome, React Fort Awesome. Cool. Let's grab this entire thing and come back over to WebStorm and do this massive install. Bootstrap, Font Awesome core, SVG icons, and there we go. So this gives us the pieces that we want, gets them installed, and there we go. So now we have our Font Awesome MySQL .env. Let's just double check. And you don't have to go this particular approach. You really could just throw them all inside your package.json and let it handle that. There's .env, SQLize, and MySQL2. Cool. So that's one of the things that you can do. You don't have to go this particular approach. And yeah, so this is our structure. Let's go ahead and actually move you into your own section. Let's get rid of you. Database. Let's call this database structure. And we'll make you an H4 tag. We'll put you, and we could probably just do a table. Yeah, let's do this. Table. Can we combine them? Let's look at what it looks like from the code side. Da, da, da. Combine tables in Markdown. Let's look. Down call span. Stack Overflow. You can use HTML tables on. Oh, okay. 1, 2, 4. Call span. Okay. So we could do TH. I see. Span. All right. So we could come down here and do. Yeah, I guess we can just do TD call span. Expand you back up here. Yeah, you can just do TD call span, it looks like. Yeah. Let's double check a couple places. Tables in pure markdown. Every row. Oh. Oh, I see. So it looks like you can just do that. So user. And nope, that didn't work. 1, 2, 3. No, that didn't work at all. Header, subheader, row. Column span, use multiple pipes. User columns will be table user. Then the columns will be user ID, email, password. Let's see what this looks like. It doesn't look quite right. Something is off. Sure. No, that should be right. Down editor. Oh, why didn't you show up right? Take a look. There. There. Okay. User and huh. For some reason it doesn't like it. We'll just have to play around with that a bit more. Or just pull it out. So let's give that some playing with. Columns. User ID. And package.json. User, columns, user ID, email, and password. Password, cool. And you're going to be good. String. We'll do varchar. You're also going to be varchar. Nope. Nope. That should be all right. Table user varchar. It's unhappy with something. What are we unhappy with? Oh, I see. So we do need that to mark the end. And then table user. Nope, still won't do it. Let's see, we actually don't need you. Columns. And let's give it user columns. Yeah. No, it doesn't like that. Playing around with this. Yeah, let's just do this. Table user. It's going to consist of GUID varchar varchar. And then that'll take care of you. We'll do the same for journal. Table journal. Journal ID, which is going to be a GUID. Read ID. It's going to be another GUID. User ID, which is going to be another GUID. Then finally a journal entry, text, and date of date time. So yeah, this is the type of stuff that you may want to just write down or take note of in your README so that when other people come along and take a look at it, they can kind of understand what your thought process was and why you were doing it, as well as seeing your structure so that you don't feel, they and you don't feel like you're just swinging in the dark. Let's put one more here. Front end is 3, back end database. Yeah, so we'll stop there for now. We'll continue this and kind of finish building the application as we kind of go along. We'll keep it pretty short today and sweet, and we'll kind of continue to add on to this as we go. So we'll get all these pieces kind of set up, and then we'll go ahead and start designing and building the application. We'll start off with the back end, then we'll go over into the front end, kind of get most of it set up, and actually kind of get kind of a polished application working. All right, thank you for tuning in. Sorry it's so short today, but hopefully we'll have a longer session on Wednesday.